Welcome everyone, and thank you for joining us in today's event where DevMethod's very own Chief Technology Officer, Paul Ort, and one of my favorite senior software engineers here, Steve Brudz, will be discussing how to ship software quickly, safely, and reliably. My name is Jennifer Imamura, and I am the Director of Business Development here at DevMethod. I'd like to take a moment just to tell you a little bit about DevMethod. We are a New York City-based custom software consultancy, and we follow highly strategic and successful methodologies, including Agile and TDD, test-driven development, we truly pride ourselves on our flexibility and our open, transparent processes, and we're always committed to keeping projects simple, yet efficient. Our dedicated team of software engineers, designers, and product managers deliver high quality technical solutions through passion, extensive knowledge, and expertise that we've seen to consistently drive successful results. Here at DevMethod, we believe in the integrity of providing quality code and in continuous learning so that we are always the best for our clients. I welcome you to check us out at devmethod.com for more information about our team, about who we are, and the services we offer. There will be time at the end for audience Q&A, so please send your questions to the chat box and we'll do our best to answer you. If you happen to miss any section or any part of today's webinar, we will be recording, and for your convenience, we will be sending that link to all participants. And finally, last but not least, at the very end, after Q&A, I will have a few additional announcements, including current job openings. Yes, we're hiring. So stay tuned until the end, but without further ado, I will pass it over to Paul and Steve here at DevMethod. Thanks.
Thank you, Jen. As part of introduction, I'm Paul. I head up software engineering here at DevMethod, and excited to talk about shipping software today. Over to you, Steve.
Great. And I am Steve Brudz. I have been shipping software for over 20 years now, and excited to share some learnings and techniques on how to do that effectively over the course of the next half hour or so. Every business has critical deadlines that they need to hit, such as trade shows or product launches. And if the team can deliver on the vision for those deadlines, then it provides a critical business advantage. And that's what, having strong software releases and getting your customers engaged, that's what makes for successful business. But teams struggle with getting large software releases out on time. So, even seemingly small features can take weeks for the development team to complete. As you get closer to that deadline, when features are finally released to the product and the QA teams, they have to go through a massive effort to review and test. The feedback that comes from those efforts then needs to be acted upon by the development team, and that causes delays in other features that they're working on. And everyone's in crunch mode, they're stressed out, and it all comes down to the wire. And when you finally do that release of the real code to production, something inevitably breaks, and there's a mad scramble to fix it. And so what I've found over the years, and my colleagues at DevMethod as well, is that small releases are much more likely to be successful. So what we're proposing is to change the goal and to perform many small releases consistently over the life of the project, which will turn the large project into many small projects. And so with a more consistent pace, you'll have less burnout, less deployment pain, and less rework. So by reducing the pressure of any one release, you can increase the possibility of achieving those business goals.
We found that releasing software frequently is especially important for enabling businesses to be able to get new features into the hands of customers frequently. And from an engineering perspective, there's a critical bug fixing component as well to the frequency of releasing, in that if it's possible to ship software frequently, it's possible to make bug fixes regularly. And the frequency with which small improvements can be made to a system is a significant factor in the perception of the quality of that system. Also the actual quality, but the perceived quality is a significant factor as well. Today we're going to talk about a few ways to release software more frequently, and a significant starting point in being able to make changes to a system more frequently is to change the definition of completion of something. So what does it mean for something to be done? As we've talked about a little bit, the ability to work on something small enough to be done in a comparatively short period of time is significant in being able to get more things completed over the course of any one interval. Over to you, Steve.
So, and in general, a lot of the lean methodologies, have found in many studies from Toyota to others, but basically the smaller the unit of work, the more easily it moves through the system. And so I've encountered this, on projects in the past where a development team is working in 2-week sprints, and we spend most of the time, most of those 2 weeks developing the features, and then 2 days before the sprint demo, we're sending that over to the product team and QA, and you've got the same situation that we described earlier in miniature. And one of the main way to address that is to split the work up into smaller pieces, slice the stories more finely, and so ideally it's a day or two at most for each unit of work, and small units of work will be able to be tested more quickly, reviewed more quickly, and that feedback can be acted on more easily.
We're going to look at some technical practices and techniques that can enable releasing software more frequently. Perhaps most significant is making it possible to integrate changes before they are ready. One of the main pain points that we see with teams that have large big bang releases and the need to ship a great deal of software at once is that there is a significant collection of new functionality to deliver to customers, and it isn't necessarily desirable to ship large new or major new features one at a time. Instead, there's an intent to gradually release them, or to stage them, stage a milestone or stage some collection of functionality. And because there often is a one-to-one correlation between the code in the system and the features visible to users, that can exert pressure on having to have more completed before being able to release software. So integrating changes before they are ready is one technique that teams often should be considering and using. Practically, this often means using feature flags or environment configuration variables to be able to selectively turn features on and off, so as to be able to merge changes before they necessarily have to be visible to customers, being able to decouple the ability to ship features and the need to have full visibility or complete all the other logistical tasks that may be involved in shipping certain functionality. Another one is to make dependencies extremely clear. There's often a web of dependencies across systems, and they can be tightly coupled and difficult to untangle. Making those interdependencies across systems clear is a key starting point in being able to understand why releases are taking so long and how to make them more approachable.
And one thing that I've often seen is that you might have sort of systems like such as a marketing site that's public facing, and kind of more of like a back end portal, and often those are developed as separate applications, but they have integration points. And when you sort of have hidden dependencies between those two, when you're not really aware that, hey, when I make a change to the admin side of things, that the customer marketing site might also need a release. That can cause problems.
I see that often with a marketing site intake form that doesn't line up with the data model on the admin portal, and that resulting in runtime exceptions that can have that deal with the ability to process new applicants or new patients or new users of some kind. Another aspect of being able to release software more frequently is to make bottlenecks visible. One of the things we've seen quite often, especially in Kanban teams, is that it's usually clear what the initial milestones or initial swim lanes should be. There's usually some stage of identifying the work or defining the work, then prioritizing it, then beginning to work on it, then reviewing it, and then approving it. But there's often a gap or some hidden stage, often see it between user acceptance completion and something being live in production for end users. So making very clear, for example, the transition, the steps that are transitions between Kanban columns or between swim lanes of work. Sometimes those transitions themselves are really need to be their own swim lanes because there is some hidden work in those areas. So especially user acceptance testing being the end state, or something being fully verified for publication, usually is some additional work for the publication of that work.
And this is one of the things that can help address that, the dependencies across the system, and it can raise the visibility of those. So if you know that as part of your release process, you not only have to test changes to the to the administrative site, you also have to make sure that the form works on your marketing site. That you want to raise the visibility of those and get those as part of your process. So if there are pain points or bottlenecks, that you can address those. So I think just thinking a little bit about how do you actually do that, because some of what we're talking about is process driven, and okay, it's all well and good, small pieces. How do I do this in practice? So we'll talk about some of those. There are certain levers that you can play with, whether it's automation, the size of your batches, and what sort of automated testing that you have in place. So just talking about automation, one of our key recommendations is make sure you've got your manual process ironed out first, well documented, clear. And I mean, this is a similar approach that it's good to take when you're building a software system. If there's for internal processes, it's important to actually know what the process is and where it's important to automate and where is important to keep manual, because maybe your return on investment won't be high enough. So start by making those manual steps clear, and use that process, follow it, and then pare down that process to the truly essential steps. Maybe there's things in there that aren't needed, or maybe there are other things that if you automated them, you could save a lot of time. So doing that in a rigorous fashion will let you basically make the best bang for your buck out of your software engineering efforts to automate things. The next lever is around batch size, and we did talk about this a bit earlier about the units of work, but there are tools that you can use to monitor this. For example, Code Climate has a commercial product called Velocity, which is interesting to look at. There's also homegrown metrics for looking at for each change request, how big is each unit of work, or how long does it take from the time a developer starts working on something to the time they actually can get it into the review process. And keeping an eye on those metrics can be very useful. And it's a good thing to look at in your retrospectives to see, how are we doing in this area? Where could we improve? Where are the pain points? And then there are tools such as Danger, which is we'll provide the link later, but it's a way to automatically kind of review your units of work and provide some sort of feedback, to others on the development team based upon whatever criteria that you set. Is this too big? Has it taken too long? Those are all things that are worth thinking about, monitoring, and measuring. And finally, automated testing. I think this is a key foundational piece to be able to release frequently. So, the more code that's in your project, the more complexity that there is, and the number of different cases so that you need to go through in order to verify that it's working correctly. That's the sort of thing that should be offloaded to automation, to automated tests, as much as possible, because you're going to hit pain points. Unless you're planning to build something quick and throw it away, if your software is going to be in use for a while, then investing in automated tests will be well worth it. And a key question to ask is, do you have, can you have confidence that once your automated tests pass, can the code be released? So, that can be a challenging question to answer, but it's a very critical one. And if you can find a way to define what that threshold is and then work towards it, for example, is that threshold, a customer needs to be able to find a product, add it to their cart, and purchase it. And if customers can do that, then we feel comfortable releasing it. But that's something that you should define consciously and communicate throughout the development team and the organization. Another key point is that it's important to have the automated build be reliable. So if it fails sometimes, but not other times, and it passes again if you just rerun it, it may seem like a small thing, but it actually destroys confidence in your test suite. So it's very important, if there is flakiness, to address that as soon as possible, and because that will give people confidence. Hey, if the test pass and I can release the code with that, and the customers won't be impacted. So it's worth investing in that.
This would be a whole topic in itself, but on making test suites more predictable and more trustworthy, I think most of the serious pain points I encounter on test suites where there are flaky tests, they usually have to do with side effects, because some behavior in the code is responsible for other operations beyond the immediate responsibility. So side effects of other features or other aspects, incidental aspects of part of the system, where the system under test is much more expansive than what it should be. That tends to make the testing less predictable. And often those side effects have to do with database integration as well. But certainly more to think through there. But would encourage as a useful test or useful assertion for a test suite, is it possible to write an assertion about a given use case or given unit of functionality and have confidence that there are no side effects, that the changes are exactly testing what is happening or what should be happening in that part of the system. So what enables deployments to be uneventful? There are there are often significant risks associated with publishing new code, sometimes control mechanisms, and sometimes there are regulatory constraints as well on teams that are allowed to release changes. So can't necessarily anticipate all of those or address all of those scenarios. There's certainly variations for why, or reasons why deployments may be more involve more ceremony at different times than at others. However, as a general rule, we find that deployments are significant events when there's a lack of clarity about what goes into a deployment. So beginning with understanding what tends to break on deployments is especially significant for finding ways to make deployments more automated, more simple, more predictable. So things that we often see break are anything involving the database, so data structural changes or data migrations, so schema migrations or data migrations. Anything involving dependencies across services, some which we've already talked about, and another less obvious one is, especially in larger systems that have longer running processes, it's possible for background jobs to be running on some older version of the code base and be in flight while a new version is released and end up with strange runtime errors in the background jobs. But any sort of background processing, especially longer running operations that might be impacted by significant changes affected by a deployment, those can be sources of breakage or a lack of clarity in deployments.
So I think one thing about releasing frequently is that you will see these pain points hit you over and over again. If they haven't been addressed, everyone will feel the pain. So it's important to, if you're going to be releasing frequently, a foundational piece of being able to do that is to be constantly looking at what deployment issues you hit, doing a postmortem on that, and having a process where, all right, if there's a problem, let's look at it, let's categorize it, and let's try to gauge how painful that was, and so the teams that are able to do this successfully prioritize keeping the system deployable over adding new features, and what that comes down to is if you don't have your system to be always deployable, and you're sort of pushing the problems under the rug, the problems are going to get worse over time. And so definitely we recommend being thoughtful about that, and keeping keeping a log, and addressing them as a priority. I think another piece is that when you do a deployment, there are often manual steps, and we mentioned this before. So that sometimes you have to do your database schema changes manually, or if you have some massive change to your data, you need to go through and split change the way you've stored the user's addresses or something like that to fit some new structure. And if there are manual steps, you should find a place to document those for the release, so that usually the person developing the feature will know, hey, X, Y, and Z needs to be done. This environment variable needs to be set when this release goes out. There should be a place which is a release prep log, where people can put in the information that's critical to releasing that. The other thing is that what happens if something goes wrong. Most modern systems allow you to roll back code, but a lot of times if your deployment actually had some database changes in there too, you have to make sure to roll back those as well. So having something in your notes that's a shared document. That's all right. If something goes wrong, here's how we could fall back. So a lot of teams, I guess a lot of teams will call that a run book. So it's good to keep that current.
Certainly a challenge to have any sort of engineering documentation remain current, but certainly a valuable aim for any team. And one stress test for the current for whether documentation is current and sufficiently developed for a team to use it effectively is to have it as a test for the ability for new team members to ship code to production after joining a team. Some teams have an internal goal of having every team member be equipped to deploy the software, perhaps as a meaningful task for their initial onboarding. If a team can have all the engineers be able to deploy software within their first week, that's something that many teams are not able to say. We find that when there is specialized knowledge or centralized control of deployment, that often becomes a major risk to the team and to the ongoing processes of being able to ship frequently. If there's a team member or a key personnel bottleneck as well, that can be a significant challenge to overcome.
And it is helpful to have, if it is a new member of the team, to have a buddy. Don't release alone especially for their first time. That's I think an important thing. And if they do find anything that is, if the instructions are wrong, that's a great early task for someone to do to update the documentation or fix the README or whatnot.
So we have a few resources that we'd like to recommend. Some we've already talked about. There's a growing body of literature on ways to measure release frequency, ways to identify particular points in engineering workflow to identify, say, the time until a unit of work is opened to a point of being able to be reviewed, to identifying different aspects of the flow of engineering work through a engineering work stream. So certainly recommend taking a look at some of the DevOps research. Much of that is discussed in the recent book Accelerate. It's being developed, it's continuing to be developed at Google Cloud.
Yeah, and actually one thing to note for that first link, the DevOps Research site, it does talk about a number of technical practices and process practices and cultural practices that can help enable continuous deployment, releasing frequently, releasing safely. But the other thing is that they have a very nice article about how to introduce changes to your process. And I think, as you think about shifting from, a big release where everyone's pushing to get it out to many, many small releases, that is a significant cultural shift. And it's not something that you're going to be able to just do overnight. So introducing these techniques one at a time, waiting for feedback, getting buy-in from the people involved at both in the business, the development team, the product side, QA. That's a critical step to making this transition successfully. So there's a great article in that first link. And the other thing is that, out of the Accelerate book, they developed 4 different metrics that they use, and the release frequency is one of the 4. And there are tools now that are coming out from Google Cloud released 4 keys last fall. GitLab just released a release frequency visualization for their sort of top tier customers a couple of weeks ago. GitHub has it on their roadmap. And there are a number of other open source projects that look at that. I've even started one myself. So there's some really interesting work going on there that's worth keeping an eye on. Finally, Code Climate, their new product Velocity is worth looking at. They have quite a bit of a number of charts and data that you can pull just out of your code repository. Some of it's a bit overkill, but some of it speaks to these ideas of cycle time. And there's an ebook that's worth looking at too.
We've also been using increasingly the Code Climate CLI, which you can install through Homebrew on macOS or through a Docker container on other platforms. And the Code Climate CLI makes it possible to script the capturing of code quality metrics on individual files in the code base. So if you are, if you want to insert some scripting of capturing the complexity measures of a file into a build process, that's now possible, or that's possible using the Code Climate CLI, and doesn't rely on, that can be isolated to run within the build process, either on a CI server or locally with a build step. So we've been using that to extract information about individual files in a larger code base where maybe we're not planning to prioritize changes across the entire system, but have certain key areas of focus that we want to be monitoring regularly. There's some useful scripting possible now with the Code Climate CLI integrations. And we mentioned briefly Danger as well. Danger is think of it as a linter for meta concerns. So you can certainly integrate Danger with regular linting tools like SwiftLint, or integrated with ESLint for JavaScript or Rubocop. We can also add linter rules or pseudo linter rules, like if changes occur in the database folder, require a change in a changelog file, or if there's some modification in a spec and no change in the implementation, flag a warning, that sort of thing. So there are highly scriptable options as well for more bespoke rules for evaluating potential changes to a code base as part of the pull request review or automated evaluation. We have a few questions. One was about addressing issues in a test suite that is flaky. That could certainly be a whole conversation in itself. One of the primary culprits for side effects in testing, especially on Rails applications or other applications that make heavy use of an ORM, is the use of callbacks on active record or similar objects, where there's a clear execution path for performing some operation, say a user object. One common example would be some spec about, or some part of the test suite that has to exercise creating a user record. And it so happens that user record, creating the user record, which should be some discrete operation, also results in the sending off of an email. And there's a separate test that asserts email presence. And because it tests other emails and doesn't account for the email that might have been generated by another test, that can cause some flakiness. Tests that integrate with the database tend to be more flaky than tests that do not, or that have completely isolated setup and teardown. Something more could be said, but I find that callbacks of all kinds are disproportionately painful in test suites.
Agreed. Let's see.
Steve, how have you? What are your thoughts on the problem of systems becoming undeployable? When does that happen, or how do you? Could you elaborate a bit on prioritizing the ongoing deployability of the system?
Let's see. Well, I mean, I think that maybe the term undeployable. I mean, you certainly could push code out, but it really, what counts is, are you confident that what you're deploying is safe? It's not going to have a negative impact upon your customers, or cause some issue with the data. So I think that it's sort of keeping an eye upon what your threshold of confidence is. And so, I've certainly worked in environments where, there was a QA group that would, in addition to automated tests and review by product managers, the QA would do a thorough test of the feature before it goes out. And, I've seen it happen for regulatory reasons. And I think it does make sense in certain cases. I'm getting off point a little bit. I guess if it would be undeployable if the people involved are not comfortable. So it's sort of setting that threshold and saying, all right, what can we do to maintain this level of quality and this level of confidence in what we're releasing. Let's see, many questions here.
So one question that came up is, what are some good questions for non-engineers to ask engineers to help engineers improve in this area, or in working in small batches or releasing more frequently? So working in small batches is a good starting point for a team to work together to develop a shared understanding of how large individual units of work should be, and aim for small versions of incremental changes. So thinking in the context of reviewing an upcoming collection of features, asking the question, is this the smallest version of that feature? Or is there, if there's an issue of work that seems to be dragging on, understanding, is there a smaller slice of this feature that would be achievable in a shorter time frame versus a larger or more complex version that is causing the work to be more significant than might have originally been intended.
Yeah.
For engineers, it's very easy to go down the path of having to figure out the problem. And I think an easy mistake to make is to assume that a feature as described, it needs to be implemented exactly that way. If new information emerges where a feature as described would take 5 days to build, but there's a version that does most of it that takes a day to build, it can be tempting to figure out every last detail or get to the bottom of the problem. And as an engineer, there's certainly a temptation to focus on engineering a solution as opposed to solving the problem that needs to be solved. And maybe the answer often is probably less engineering.
Yeah, though sometimes, if that's what the customer needs, then, sometimes a larger solution is called for, but you can still break it down into smaller pieces.
Definitely.
All right. Let's see. So I guess we're skipping around here a little bit, and I'm conscious of time too. Let's see. Yeah, I mean, I guess maybe the go-to platforms for shipping software quickly, reliably, and safely. I think these techniques we're talking about are generally platform independent, and platform choice should depend on the needs of your software project. If you're building an iOS application or doing embedded software, or it's a web application, you're going to make different choices as to which platform to use. Though I think all of the modern cloud platforms, whether it's Google or Amazon, or Microsoft Azure, like they all have APIs that make automation easier. So if I had the choice, I'd tend towards an established platform as opposed to building one from scratch. But as I said, a lot of that depends upon the project.
Definitely see many projects that can and probably should use a platform as a service to distribute an application, something like Heroku or Amazon Elastic Beanstalk or Cloud 66, some mechanism that is optimized for building a 12-factor application, a specific flavor of deployable software. There are too many teams trying to build large Kubernetes clusters these days, when they really should just be using something like Heroku. But that's also a different a topic for perhaps another time. Maybe we have time for one last question for handing it back to Jen.
Let's see. When you said elevate, what do you mean by elevate certain parts of your process, testing, planning, design? What does this elevation look like? Can you paint a real world example? Let's see. I mean, I think some of that is some of these techniques that we talked about in terms of paying attention and setting goals and saying, you know, so if you do, let's say, a look at the way work flows through, you know, from the time that you first write a story until the time that it actually can get released into production. And, you know, you look at each of the handoffs and the stages that it goes through, and you identify the different pain points or the bottlenecks that you're hitting, and then you try to quantify, all right, where are we hitting pain points? Where's there a bottleneck? And then you do make a change. This is, I think in my mind, this is the elevation of saying, all right, well, we're gonna improve this particular area, and we're gonna try to do this, and we're gonna measure its impact upon that. And so, I think an important key is to change one thing at a time, so you can see if your change had an impact, which is it's essential to sort of the scientific method, if you will. So that's I guess that I don't know if you have anything to add to that.
One elevating question that's often useful is these bottlenecks often show up in a significant amount of work in progress in some stage. So getting to the bottom of the question, why are there so many things in progress, and not allowing the comfortable, it's almost there, or I'm just figuring out a few more things, or it's mostly done. There's usually some reason why work is piling up in a work in progress state, and as I argued earlier, I think one major cause of that is that when work piles up in some category, say it's in development or in code review or in some stage of a development process, often a reason it piles up is because there's a missing process step that hasn't been identified, and making that visible will help to clarify why things are, or make more visible the work that hasn't been accounted for, or that is perhaps assumed and not made clear throughout the flow of work. Thank you all for joining us today. I hope this has been interesting and useful. Certainly recommend exploring some of these resources further. There's a great depth of material to explore on all of these themes. Thank you, Steve. And back to you, Jen.
Hey there. Sorry, I was trying to get my lighting here because it's a little dark. Sorry about that. Thank you everyone for joining. We appreciate you hanging out with us. As mentioned in the beginning of our event, I do have a few announcements. We provide free, go back one, thanks. We provide free engineering and product consult office hours where we have conversations like today's. We'd love to be able to help you to figure out maybe a pain point that you may be facing. If you're stuck on a project and you're working on something very specific, need a little help, we can provide a little expertise for you. we love to help. It's everyday problems that keep us on our toes, and we as consultants love helping others get through these challenges. So feel free to sign up for any of our office hours. The links are there. You can also find those on our website. Please follow us on any of our social media. We are on LinkedIn, Twitter, Facebook, and we have a blog on Medium. If you haven't already signed up for our monthly newsletter, please sign up. It's pretty awesome. We have tips and tricks and discussion points, and we always announce our next event. Also, something very exciting is we are hiring. We're currently hiring for senior software engineers, as well as a senior product manager, and last but not least, a senior account executive, where you get to work with yours truly. Of all these roles, all of these roles are posted on our website. You can find them near the bottom of our homepage in the orange and yellow banner. Just click on that Join Our Team button, and you'll be on your way to possibly joining our team. We look forward to hearing from you. So if you or anyone you know is looking, please check it out. We appreciate your time, and we look forward to seeing you at our next event coming up in March. I believe that will be a product management or design focused event. So that will be very cool. Look for that in our newsletter. If you have any questions, please feel free to reach out to us at info@devmethod.com. This concludes our event for today. I hope everyone enjoyed our discussion. Thank you again for joining us. We look forward to seeing you next month. Thank you.